I don't know if you go back and watch the videos, do you? um. So what's the unit for force? Newtons. Why does a piece of paper fall slower than a boulder? Yeah. What if I drop the hammer and a piece of paper? Why does the piece of paper fall slower? It does, but that's not a reason. So if we had a vacuum and I dropped a piece of paper and a bowling ball, which would hit the ground first? Yes, if I removed all the air. Same time. So why, when we add air, does paper fall slower? Air resistance, right? Yes. Air resistance slows it down, and air resistance is based on surface area, and also because of its mass. So there's two forces. There's the force of gravity. The force of gravity is different. It just so happens that if you weigh less, then the air resistance force is going to cancel out more of the air, gravitational, so your acceleration changes. But it's air resistance that does it. And this is mostly done from the surface area. Uh, if you were standing on a boat and you were to jump out, what would happen? So you're at the dock and you're standing in a boat and you were to jump from the boat onto the dock backwards. And which law is up? I mean, you can argue that, but that's not the better one. For every action has an equal and opposite reaction. Yes. So you are putting a force onto the boat, and that's causing it to start moving. But this more demonstrates the third law for every action. Your action is you jumping forward. The reaction is the boat has to move backward. So what's the definition of inertia? No, inertia, not the law of inertia. What is inertia? It's the tendency of an object to remain at rest or in constant motion. So when you say something has large inertia, it's hard to get it moving. This is actually inertia better explains why two objects move at the same rate. So we have a vacuum, and so no air resistance. We have a feather. A feather has very little inertia, so it's more easier able to move. So you drop a feather, it's more able to move down to the ground very quickly. You have a bowling ball. Bowling ball, again, because it has more mass, it's going to be pulled downward more strongly. However, it also has more inertia, so it's going to resist changing its motion to fall down than the feather. So the feather has a little force on it causing it to move down, but it doesn't resist too much, so it falls down at 10 meters or 9.8 meters per second squared. Bowling ball is going to be pulled down way more strongly, but it has more inertia, so it's going to resist that motion. They both resist in such a way that their acceleration is constant. I don't have it on the test. If you want me to write down the kinematic formulas, you do have to memorize F equals ma. You also have to remember the equation for torque, RF. You don't need to know the sine theta because we're only doing 1D. you can assume that in all the problems that the forces are perpendicular. So know how to apply F equals ma. Know how to apply torque. I'm making sure I didn't ask this yet. Yeah, we don't get into rotational velocity yet. We only have introduced torque in this unit. I don't think I had a pulley yet. So let's say we have a pulley. We have a rope on both sides, so the pulley will start rotating. And let's say that I put on this side a 5 kilogram block, and on this side I put a 10 kilogram block. And let's make this. Let's put here and make this 5 centimeters. So this has a radius of 5 centimeters. What is the torque created in the system? So force is, or the weight of it is mass times acceleration. So the mass is 5 times 9.8. $49 newtons, and then this is 98 newtons. The force here. We also need to convert centimeters. So what is 5 centimeters equal to? 0.05 meters. So we have two torques. The torque here would be equal to 0.05 times 49. So the torque on this side is 2.45 Newton meters, and it would make it want to rotate counterclockwise. The torque here is 0.05 times 98, which is equal to 4.9 Newton meters. And this would make it want to rotate clockwise. So to figure out the total torque, we add these together. So that would be negative 2.45 plus positive 4.9. And I'm assuming that my positive direction is clockwise. And so I get a total torque 2.45 is positive, so basically this will start rotating faster and faster and faster. I believe that's it. Know how to do some F equals ma? I don't think I have any kinematics actually on this test. Make sure to include direction. Number one thing is when you see north, north is not in that direction. That's east, right? This is pointing east. Technically, if you look at it now, pointing northeast. you should write direction as north, not with an arrow. But that'll be the test. We will have it on Monday. Oh, I did get approved.